Okay. Then we'll go right to the right place. Okay, good. Okay. Okay, let's go here. Yeah, you did see 48 seconds of me getting ready. Okay. I'm gonna wait a few minutes. Probably start at 1:10 and no one's joining. Oh, I can see on that one. Okay, so it's about 5 seconds. Only 1:10. May or may not join. They might have some of the class they're doing today. It's quite possible. Okay. Hey Daniel, gonna start in 2 minutes. The notes are 3 pages, but there's pictures. So probably 40 minutes at most. Maybe 40 minutes? Yeah. I mean, I condensed some of the book, so we're skipping some of the things from the book because I don't think they're useful. So, yeah. Do you have something else you need to do? I don't want to be visiting a lecture that lasts more than 30 minutes. Okay, I'll start in a minute. I was about to start, but I realized I did say 1:10, so, you know. Okay, now I'll start. Okay, so we're going to talk about the main, like, one of the main chunks of calculus, and this idea is so important that honestly, if someone was to say, if you took out everything with pre-calculus and only could keep one thing to prepare something for calculus, what would it be? And I would say this chapter, and particularly this section and the next section. So section 12.3 and 12.4 and 5 all build calculus. Oh, hi. So we're talking about 12.3 today. I got Henry and Daniel, the two faithful comers, two faithful visitors. Okay. I like how people write Korean because I can definitely understand it. So we're gonna go over the notes, and if you have any questions, you can feel free to ask. Okay, we're gonna talk about tangent line, and essentially a tangent line is our slope. So the way we say it is the tangent line of is, sorry, well that's not bold, is the best approximation of the slope of a function at a point. Okay, so you think of a tangent line as only hitting the graph at one point and gives us the slope of the function at that point. Now, what's crucial about a tangent line is it actually does correlate with what we learned in trig. Tangent lines do correlate with slope. Okay, so if you look at some of these graphs, you can see the tangent line. So that's a tangent line. That red thing, that's a tangent line. The example I would say is if you look at these, we don't know the slope from what we've been taught. So it's not clear what the slope of a graph is at a point. Now, if you're wondering why would we want this, this is so crucial for so many scientific applications. Specifically astrophysics, or physics in general. This is useful for chemistry, predicting models, modeling problems is really crucial to find the slope at a specific point to find. So we're used to slope equal, example, rise over run. I wonder if this is going to work. Or we're used to equal, change in y divided by, change in x. So we're used to this. Sorry, I don't really like having parentheses on top. Probably could have done it without parentheses. Okay, let's just remove the parentheses. Or, we're even used to, from algebra, y2 minus y1 divided by, x 2 minus x 1. Okay, we're used to that. Okay, that's the basics of slope. Now, this is actually pretty accurate, but it's going to change, okay? So first thing we need to know before we go is we're going to talk about secant line. A secant line, for the purpose of calculus, pre-calculus, is a line that passes through 2 points on the graph. Okay, so it passes 2 points on the graph. So a tangent line is 1 point, and secant is 2. And if you can see this right here, this is our secant line. H is going to be crucial. H is a just kind of arbitrary number, okay? Arbitrary number that we're going to figure out. Arbitrary meaning it doesn't matter what it doesn't matter what the number is at the beginning. It matters what the number is going towards. So the slope at this is actually going to be a limit. So it's going to be a limit here. And the limit is going to be as h approaches 0. So again, we're still using limits. As h approaches 0, m secant, we're going to get, that's going to equal, again, the limit. It's going to be a limit. It's going to be as h approaches 0, so nothing really has changed significantly. As h approaches 0 of, so we're going to plug in f of x plus h minus f of x. Okay, and this is all divided by h. Oh, and good. See, they don't want me to put parentheses, but then they do want me to put parentheses. Okay, divided by h. Now, if you notice something about this formula right here, okay, let's plug in h equals 0, okay? Plug in h equals 0. So this would be 0, right? That would be 0. So then f of x plus 0 is just f of x. So f of x minus f of x is 0. Well, what's on the bottom? 0. So this formula, note, this will give us a, let's stop right here. This will be an indeterminate form, okay? This will be an indeterminate form, okay, right here. That's crucial because that means we're going to have to cancel out stuff and do some math to solve it, okay? So generally, we're dealing with an indeterminate form when we find this. And this is actually going to be very crucial for calculus. I would like bold it, stick it in your memory. That formula right there is going to be in calculus. Okay, so what happens to this graph is h, this h right here, approaches 0. So as h gets closer to 0, the distance between these 2 points gets closer and closer. What's going to happen? Well, notice this. So the line, the angle or the slope of the line is getting closer and closer to our tangent. And in fact, this progression is what calculus is all about. So progression closer to infinity, or closer to 0, is calculus, okay? Okay, so we're going to define the slope of a graph, because, so the slope, let's bold it, slope m of the graph f at the point x, comma, f of x is equal to the slope of its tangent line at the same point, okay? At the same point. So x, comma, f of x. So, and is given by this equation. Okay, what's our equation? Great question. The equation is m equals, so that's our slope, equals the limit as h approaches 0 of m secant, or better yet, this is the limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay, this is the formula that we had way up here. right here, this same formula is our formula for the slope, okay? This is the new slope formula, okay? Got it, stick that in your memory. Limit h approaches 0. I would even memorize it. Limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay? That formula is going to be crucial in calculus. So if you're like, what should I study this summer? I would go chapter 12. Review chapter 12, review some sine and cosine. Get that stuff stuck in your head. That'll be helpful. Okay. So we're going to do example 3 and 4 and numbers 11 and 9. Okay, we're finding the slope of the graph at a point. This is actually going to be pretty straightforward as we go, right? But if we do it wrong, it's going to feel more complex. Okay? Okay, so let's find the slope. Now, you're going, how do I find the slope? Okay, well, great question. So we have our formula. You honestly should always write your formula. Sorry. Don't like ants on my desk, even though they need a place in this world. So we have our slope. M equals what? F of x plus h minus f of x, all divided by h. Okay, so we're just going to plug in x plus h into, what was our original equation? So f of x was equal to x squared. Okay? So we're going to plug x plus h into this equation right here. So what we're going to get is we're going to get the limit. You always need to write the limit until you solve it. You're going to get x plus h squared minus x squared over h. Okay? So let's solve this out. That's the first thing. Now we're not going to plug in the 0 yet. So we're not going to plug in 0. So we're going to do a few more steps before that. Some reason this is rather small. I'm going to blow this up a little bit. Forward, transition. Okay. Okay. So, hey, Chunks Up. Are you getting your stuff for graduation?
Yeah. What are you doing?
I'm teaching math.
You're teaching?
Yeah.
Is this live?
It's live.
Oh man. Whoa, dude, this setup is crazy.
Yeah, but
Village. You know, social distancing, man.
dogs don't understand. So, anyway, Chunks Up is here visiting us. This is Daniel and Henry are the only ones watching.
Oh.
Because all the other people are either, busy or sleeping. That's my understanding of this time.
Oh, it's so nice to be back.
I know, isn't it weird that you're like...
So weird. Like, oh.
I know.
Weird.
I know. I live on this campus and it is so strange having no one here. Just doesn't make sense.
Even Nathan, Kristen, and all.
Yeah.
How late?
There you go. Yeah, so it is a strange feeling. I mean, the workers come in on Monday, but it's like, yeah.
Weird stuff.
I bet it's weird, having classes online.
Super weird. Across the tools.
Yeah, well, that's what college is like if you... Hey. Yeah, okay, hi, yeah.
Can you hear them?
Can they hear you guys? Yeah, they can hear you guys.
Like, can you hear
Them?
Yeah.
No, they just put in the chat. They haven't said anything while we've been talking. They're probably like, why is Mr. David talking? Or they put it on mute. See, they put it on mute and then they come back to it later. So it's just, okay. Doug's smelling like
Alright, please.
Stop that.
Stop. Good luck.
Okay, so subtract the x's and you get,
Did they see me?
yeah, they haven't sent any comments.
Yeah.
See ya.
Oh.
Okay, so we cancel out the x squares, and we get 2xh plus h squared. Sorry about that. And then we're going to, you see how there's h's here? We're going to factor off that. So we get h on the outside, 2x plus h. There's an h on the bottom. Now is the point where we can cancel the h's. So if you're wondering, this would be an indeterminate form way back, here, so we don't really need to actually worry about showing it's indeterminate over here. Okay, so then we cancel out these h's, and so we get limit as h approaches 0 of 2x plus h. And then you plug it in, 0 for h, you get 2x. So this is going to be our slope, but a slope at a point, so this slope is going to be m equals 2x, and if we have a point, negative 2 comma 4, we just plug in negative 2 in for x, so we get m equals 2 times negative 2, so m equals negative 4. Okay, and that's your two solutions right there. Okay, let's try another one. Try to find the slope of, okay, okay, so we have f of x equals negative 2x plus 4, okay? And so we're going to find m, so m equals the limit as h approaches 0 of f of x plus h minus f of x. Okay, that's all over h. So if I plug in x plus h into here, we get the same thing, limit as h approaches 0 of, wait, why are you visiting a second time? Okay.
Peanut butter, yeah. Are you teaching?
It's just the negative. You got both, Daniel. I know I am teaching, but then Daniel Jung-hoon is saying hi to you. He can't see you here.
Oh,
Here, jumps up. You wanna get a video so they actually see you? Welcome. This is Henry.
Is this a YouTube live stream?
Yes.
Wow.
Woo, dub.
I heard you got reported.
You got reported by 8th graders.
You got reported.
By 8th graders, man.
How'd you get, like, that's so sad.
That's so sad.
And then the fact that I used the school account, so I couldn't actually go to my defense and re-upload anything.
Oh.
So it's all deleted. It's like unaccessible.
I felt that. It was like,
I was like,
8th graders are so smart.
I was like, no, but the thing was that actually hurts them, so they can't use any of those videos again.
oh, that's so sad.
I mean, you could say they were used.
Oh, Mr. David.
Yeah.
You're like,
I was like, that's just stupid. It's okay. It's part of life.
oh, dude, this is so funny. Yeah.
So we're gonna subtract here. Let me actually write this larger. It's probably not an 8th grader. It might be 8th grader. Okay, I'm gonna write it larger. Okay, so we're just plugging x plus h in for here, so we get negative 2 x plus h plus 4 minus, so minus negative 2x plus 4 over h. Okay, and then we're just going to do the math on the top. So we're going to get limit as h approaches 0. So you get negative 2x minus 2h plus 4 plus 2x minus 4. It's all over h. So what's going to cancel is these two x's, this 4 and this 4. So what you're going to get is limit as h approaches 0 of negative 2h over h. The h's cancel, and so our solution is negative 2. So m equals negative 2. Now, the funny thing is it doesn't matter where you go on this line, it's going to have the same slope regardless because this is a constant. So you don't have to worry about its slope beyond it. Okay? Okay. So, yeah. I wonder about that. Okay, so we're gonna try out this problem. So find the slope of g of x equals x squared minus 4x. And you're finding at the point 3 comma negative 3. So try this one out. Okay, you're gonna try to find the slope of this one. Okay, I'll give you a minute to work it out, and I'll start after that minute. Okay. So hopefully, we're already on page 2. Oh yeah, we're on page 2. We're almost on page 3. Yeah. So I can give you a solid minute to work this problem out. Yeah, this is page 2. This is one of the examples. Okay? So page 2, work this problem out. And if you have any questions, you can ask it. And otherwise, I'm going to start. Okay? So I'll give you a minute. I'll play some bend sounds. You know, get my money's worth of a free source. Let's do because free sounds good. Okay. So I just again start with the formula. We then plug in x plus h into x squared here, and x plus h into the 4x right here. Okay, then we subtract f of x, and then we're going to just solve this out, okay? So we get limit as h approaches 0 of x squared plus 2xh plus h squared minus 4x minus 4h. Okay, and then that's going to subtract x squared plus 4x. Okay, then we're going to cancel out the terms. So x squared and negative x squared cancel. Negative 4x and 4x cancel. And then the rest is going to stay, okay? The h squared, the negative 4h, and the plus 2xh. Okay, so I'm going to just continue this at the top. So then we're at the point where limit as h approaches 0 of 2xh plus h squared minus 4h all over h. Okay, and notice the top again. You've got to notice there's an h in all of this. So let's, before we do anything, before we ever take a limit, it's best to simplify. It's kind of the rule in math. If you can simplify, do it, because life usually is better that way. Okay, and what do we have? We have an h and an h, which can cancel. Once we cancel it, sorry, it's crooked. It's because it's kind of crooked. Maybe that'll work. Okay, so then we get limit as h approaches 0 of 2x plus h minus 4. Well, what's h? Plug in h equals 0, so our solution is 2x minus 4. That's our answer. That's what m equals. But what's m at 3 comma negative 3? And all we do is plug in 3. So we get m equals 2 times 3 minus 4. M equals 6 minus 4 equals 2. So those are our two solutions. Okay? Okay, so those are our two solutions. Okay, and that's how you find the slope. So Daniel, you do box both answers. It's the best way of approaching it. Okay, what about finding the formula of a slope of a graph at different points? So what you do is you do the same process, and then you're going to plug in two different points to find the two different slopes. Okay, and then we're going to get a derivative, and we'll be finished. Sounds good. We'll finish maybe here up in the last 8 minutes. Okay. Okay. So again, we first start with our formula. F of x equals x squared plus 1. Okay. Then we find m equals limit as h approaches 0 of f of x plus h minus f of x over h. Okay, plug it in again. Approaches 0. You're going to get x plus h squared plus 1 minus x squared plus 1 all over h. So again, we get limit h approaches 0 of x squared plus 2x h plus h squared plus 1 minus x squared minus 1 over h. Can we cancel anything? Yes. Yeah, you boxed both. Okay, so the 1's cancel and the x squareds cancel. So then what is left is going to be 2xh plus h squared over h. Okay, so then you're going to get the limit as h approaches 0 of 2xh plus h squared over h. Again, take notice there's two h's on top, or rather both. You can factor out an h. So you factor out an h, you get 2x plus at h over h. Cancel the h's. So you get the limit as h approaches 0 of 2x plus h. And what does that equal? Well, that just equals 2x. They gave us 2 points, negative 1 comma 2 and 2 comma 5. So we have m equals 2x. We're just going to plug it in. So m at negative 1 is going to be 2 times negative 1. It's going to be negative 2. And I'll write to the right. M of 2 is going to be 2 times 2 is going to be 4. So our two answers are negative 2 and 4, respectively. Okay? And that's the answer for a question that asks you to find the slope at points. Okay? So, last part of this section is derivative. And the derivative is this is it. This is calculus. Well, it's the question. What does the question ask? So the question asks find the slope, then you find the slope. And that's where you box. The question asks find the slope at 2 points, then you box the slope at 2 points. Sorry. Is a great thing. Okay. Derivative. Now, the derivative, if you want to do physics in the future, or calculus, this is it. So, we're going to blow this up so you can see it. Always blow up the screen. There we go. Okay, the derivative. So the derivative of a function f, of f at x is given by this formula, okay? Now again, it's f, you see this little apostrophe of x. That means f prime at x, okay? So it reads, so I'll write it below. It reads f prime at x equals, and again, derivative is literally the slope, okay? X approaches 0 as f of x plus h, so as h approaches 0 of f of x plus h minus f of x divided by h. And that formula that we've written 3 times is crucial. And this right here, okay, let's create some space. I know that means we're continuing on the next page. Not really. It just means, actually, I don't need the extra space. I'll just write it to the right. Okay. So you see this f prime of x, okay? That is equal to f prime of x, okay? Or the derivative of the function f of x, okay? This is crucial stuff right here. So this is the meat. This is calculus. Beginning of calculus is limits, okay? The beginning of limits is this, beginning of derivatives is this idea right here. It's finding slope at it. Now, it provided the limit exists, okay? If the limit doesn't exist, this doesn't work. Or you have to do some funny stuff. And we're not going to talk about that funny stuff because you're not going into Calc 3 or differential equations. If you do those stuff, then we can talk. Okay, so we're going to do these 3 problems. Actually, we're going to do 2 of them. I'll do this first one and this last one, and then we'll do this one together, okay? Which means there will be a problem that you can do by yourself. Okay, sound good? Sound great. We're at 40 minutes. We're going to finish here in the next 5. Okay, so let's just gotta blow this up. Boom. There we go. Okay. Okay, so we're gonna start with f of x equals 3x squared minus 2x. So we're finding f prime of x, which equals the limit as h approaches 0 of f of x plus h. I don't need to write this every time. I'm writing this so that it gets stuck in your head. F of x plus h minus f of x divided by h. Okay, plug in the formula. Plug in the function. H approaches 0 of, let's blow this up, 3x plus h squared minus 2x plus h minus 3x squared minus 2x. Again, this is all over h. Okay? So it's going to be crucial that we see this. We're going to just we're just going to solve this below. We still get the limit. So we always remember our limit until we're finished. Okay? So solve it out. We get 3x squared plus 6xh plus 3h squared minus 2x minus 2h, and then this is minus 3x squared plus 2x. Okay, I know you can't see that, but that goes all the way over there. Okay, it's very long. Okay, so what can be canceled? Well, in this case, the 2x and the 2x is going to cancel. The negative 2x and the positive 2x is going to cancel. The negative 3x squared and the 3x is going to cancel. So we're going to have 6xh plus 3h squared minus 2h all over h. Okay, that's what we're going to have. So after plugging it in, we're going to have this. So we're still at the f prime. Okay, f prime of x is going to equal the limit. We haven't taken our limit of h. Of 6xh plus 3h squared minus 2h over h. Okay? You see that there's an h in the top in all of them? Yeah? I guess. So then we're going to factor off h. So we get limit as h approaches 0. Factor off an h, we get 6x plus 3h minus 2 over h. Remember, we can divide out things, so we divide out the h. We get limit as h approaches 0 of 6x plus 3h minus 2. Put h in as 0. Now we can plug it in because we won't have 0 over 0. So we get 6x minus 2. And that is our slope. So we say f prime of x equals 6x minus 2. Okay? And actually, there is a pattern with this right here that you should be able to find f prime of x even if you don't do the limit formula. But you need to do it at the beginning. Okay? So, we're going to go over this one. This is the one it's going to be not longer. It just takes a little bit of time. So we're going to take the square root of this right here. And so we get, I'm going to write this over here, f prime of x equals, and now I'm just going to I'll write it still again one last time. So we go f of x plus h minus f of x over h. Okay, so I'm just plugging in x plus h into here. So I get limit as h approaches 0 of the square root of x plus h minus 11 minus x minus 11 over h. Now, the problem is we can't do anything with this right here, okay? But we, again, to rationalize this numerator, because it's 0 over 0 at the moment, we can rationalize it by multiplying by the conjugate. So I'm actually going to write this equals over here, because otherwise it's going to be way too long for this board. So we'll get x plus h minus 11 minus square root of x minus 11 over h times the conjugate is x plus h minus 11, the square root of x, plus x minus 11 over square root of x plus h minus 11 plus x minus 11. Okay, we're rationalizing the numerator here. So we multiply by a conjugate, which means once you multiply by a conjugate, you're going to get, so the top is just going to become all without it, without the square root, so you're going to get x plus h minus 11 minus x minus 11. Okay, and the denominator is going to be h times square root of x plus h minus 11 plus square root of x minus 11. Okay, then the numerator is going to cancel, the x's cancel, the 11's cancel, and so all we're going to get on the top is an h, so we get limit as h approaches 0 of h on the numerator, h in the denominator. What do we know when we have both of those? That we're going to cancel some stuff. So the h is canceled. So we're going to be left with, the limit as h approaches 0 of 1 divided by square root of x plus h minus 11 plus the square root of x minus 11. And what does this become? Let's plug in h equals 0. So we get x minus 11. So we get 1 over square root of x minus 11 plus square root of x minus 11. And what happens when we have two of the same things and we're adding them? That becomes 1, 2, 2 times. So 1, 2 over x minus 11. Now you could actually write this a different way. So there's two ways of writing this. So there is f prime at x equals 1 over 2 the square root of x minus 11, or you could say 1/2 times x minus 11 to the negative 1/2. Okay, both of these are the same thing, so either one. This is an or. Okay. Both of them are correct. This one's more common. So what's funny is the first one is the one we're going to probably get on our own. The second one is the one we're going to get as we do this problem more. Okay? And there's even more than this, but we aren't going to go into all of that. So we're going to do one last problem. And then we will be done. Okay? So we're going to have, first we're going to find f of x for the square root of x. So we're going to find f prime of x, which is limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay? Put in our equation, we're going to get limit as h approaches 0 of the square root of x plus h minus square root of x over h. Now if you notice something here, we will get 0 if we plug in h as 0. So we're going to get 0 over 0. So we're going to just multiply by the conjugate the first step so we don't have to do it later. So we're going to do this right here, multiply by the conjugate. Conjugate over here. So then we get the limit as h approaches 0 of the square roots at the top numerator are gone, so it's x plus h minus x The x's are going to cancel. Bottom is going to be h times the square root of x plus h plus square root of x. Okay, the h's are going to cancel in a second, so we're going to get limit as h approaches 0 of h over h times square root of x plus h plus square root of x. So the h's cancel. So then, come back, we're going to get, it's going to equal limit as h approaches 0 of 1 over square root of x plus h plus square root of x. Plugging in h equals 0, we get 1 over square root of x plus the square root of x. This equals 1 over 2 square root of x. So you say f prime of x equals either 1 over 2 root x or 1 over 2 x to the negative 1/2. Okay, so that's one of our solutions. That's one of our parts. The other part is plugging in a point. And the point we're plugging in is at 1, 1. So all we're doing is plugging in f prime of 1. And we're going to get 1, 2 times the square root, 1. It's going to just be 1/2. There's our solution. So we have two solutions, the point and the f prime of x. And guys, that is the end of our lecture. I know it was a very fast one. So that is the end of our lecture. Thank you for joining. If you have any questions, feel free to ask me. I will still have my, you can email me or something like this about this. But yeah, this is crucial for calculus. So again, the homework for this will be most important. Okay? Thank you guys. Have a great day. Bye.